So, okay, let's start again. Have you had the chance to figure out the problem? So, what is the problem in this code? We have a bunch of algorithms that we want to use. Depending a little bit on some arguments, we select which type of algorithm we are to run. And we have a bunch of code also in this class. You can imagine that this class is pretty massive, probably. So what problems can you see here? Yeah? Yeah, of course it has something to do with this type of algorithm stuff. And this is a bad way of doing this sort of thing. And this leads to the problem that Svante here also addresses. You have no validation in the constructor. What if I send in 7 and 52? We will probably get some kind of unknown behavior, and the value that is set by default here will probably be returned. But the main problem is here that we are switching here. We are selecting based on type, and that is a problem because we do not take into account the polymorphism principle, that you should avoid selecting based on type. So what should we do if we have selection based on type? So we have this problem, selection of algorithms based on type, and in this case we have integer IDs. And what should you do if you have this problem? You can take a look at the polymorphism pattern, of course, and it says that, okay, we should use polymorphic operations instead. And in this case, that would result in a huge amount of base classes. Since we have 2 variations of algorithms, we will probably get 9 different subtypes to implement. And that is maybe not the best solution. So, but it is definitely better actually than having this type. So, is there another pattern that is used to implement or encapsulate and provide the ability to change algorithms? Rasmus here in the chat says split in classes that implements interfaces. Yeah, and that is basically use the strategy pattern. So the task is now to use the strategy pattern. And what should we do? We should probably construct 2 interfaces, one for the algorithm type 1 and another interface for the algorithm type 2. So Seems like it returns an integer. Do algorithm. It takes no arguments, so that's about it. Two we have there, and it takes an integer. And we don't really know that much about it. Maybe we could take a look here. Number, so let's use that fine name then. So these are the interfaces, and then we of course need to split out the algorithms into implementations of these interfaces instead, and well, they will just be the same thing. Class algorithm 1b. We must do that, and we must do this. So something like that. And for type 2, we could just copy this. And maybe we should so, and I won't be adding all the others here because it is fairly obvious what we mean. So, all right. And this foo class, instead of looking like that, it will look something like this. First. Let's make it a little bit easier. We could call them do algorithm, both of them, so won't be any confusion. So the code will look something like this in the foo class, and just to make sure we have an example of the usage also, we could just add the same example, and it will look something like this. We had this code to start with. Pop something like that. But instead of sending in 1 and 3, we should new. I'll go and the third one will be so something like that. So we decided to use the strategy pattern. We had 2 different types of algorithms to make interfaces for. So we did that, and we moved the algorithms out into classes of their own, implemented the interface, and then we could send in objects of these algorithm types into this foo type instead. And we got type safety, and we got a really small amount of code in this class. It's kind of like just uses the result from one algorithm and puts it in the next and returns the result. Questions? Yeah?
Why use interfaces is just as good?
How do you mean?
Like, we don't even need the interfaces right here.
Yeah, we do.
If you remove them and don't implement them, wouldn't they go exactly so?
No, it wouldn't compile because this wouldn't exist. And that wouldn't exist. So this foo type is dependent on the interface and not on the concrete implementations. Because we have a lot of implementations here to add actually 2 more on each. So the question was if the interfaces are necessary, and they are. Any other questions? Do you think it will be a problem to do a class diagram for this? So you will have 2 interfaces, you will have 3 implementations of each interface that use this realization relation instead. One question from Svante: is the use of an abstract base class also strategy pattern? You mean if we have some kind of implementation in these? I guess basically it would be a strategy pattern anyway. If you can if we could find any code in these implementation of the algorithms that are common, well, maybe you should move that up to this interface then. I would probably not do so. I would probably make a base class, just as we did in the number 1 task, so to speak, 1 level below, because you never know if you have an implementation that does not conform to this base class, then suddenly you need to change it back and, again. it would be somewhat clearer if you could see the solution and you could see a diagram. Yeah, you could skip the interface and use a base class instead. The problem with that is, in the event of that you have an implementation that does not conform to this base class anymore, then you need to change it back to an interface again. So an interface is, being dependent on an interface is better than being dependent on a base class, because we have no implementation and no assumptions of implementation if we use an interface. But we can make a class diagram for this, so you get to see how it would look. Oh, not before and after. So basically we have this, was it foo? And we have an interface. And we call that interface algo type 1. And we have another interface. And we will have 3 implementations. Of each interface. Something like that. Then we have 2 associations here, and they are called algo 1 and algo 2. So something like that. No. What? You mean this? It's the realization. You use that when you have interfaces. So it's not... Yeah, if you have inheritance, so you have something to inherit. That is, you inherit from an abstract class or from another class. Then you use the generalization specialization arrow. I would probably not mark you down for making such a mistake, because it does not change the meaning of the diagram actually that much. Because I know this is an interface, and if you use inheritance here instead, well, I can probably know that you are trying to implement this interface and realize it, and you should actually use this dashed arrow instead. The big mistakes you can make is make this a dependency, so you have an open arrowhead here. Then the diagram changes meaning, so that will be a problem. And the same thing, that is probably the most... Why did they disappear? That is probably the most serious mistake you can make in your notations. If you make a closed arrowhead on an association, but still have the role name here, well, then you can probably see that, okay, it is an association and not inheritance. But those are the mistakes you can make that change the meaning of the diagram and makes the reader really confused. So don't mix the dependency and the realization notation, and don't mix the association and generalization specialization. On the test, what sort of diagramming software should we use? Well, you are free to use any diagramming software that you would like to use. Pen and paper and mobile camera is probably the easiest. You could do them in Paint if you would like. You could. It is okay to send a picture of some form. I would actually prefer a picture because I can't have every type of strange software installed and open your special files in everything. So it should definitely be a picture that you send in. But if you use a tool to construct that picture, it is up to you. Online tools like YUML and web sequence diagrams are fine to use. Remember though that they sometimes have a little bit of performance problems, and it is not fun to sit in the last minutes and try to get the syntax and an update right to get the correct image. And especially if we have like 100 people using these services at the same time, I have no idea how they will perform. So it is a good idea to at least have pen and paper and a camera available as a backup if things don't go well. So you probably don't even need a computer if you well, you will need a computer to get your assignment. That is what you will need, but not to complete it. Yeah, probably. So, any question on this assignment? No? So it's about the strategy pattern, basically. Knowing how to use and the strategy pattern in a correct way. No, I don't think so. I think it's just a class diagram that is needed. Yeah, a class diagram. So the question is, how much time do we have on the exam? The exam will probably be for 90 minutes. So the exam will be open between 10 and 12, and you will have 90 minutes to complete your exam once you have got it from the web page. And that is a little bit to spread you out, so to speak, during this window, so that not everyone tries to access the exam system at the exact hour of 10 o'clock. So how does that work with sending in picture? Well, you will have an URL to upload your exam to. So either you create a document or a zip file or something with your answers in it and just upload it to the exam system. Hopefully there should be no problems doing this. Ja.
Uppgifterna är ungefär, du sa 3 uppgifter, är de ungefär så här stora som
Yeah, the assignments will be somewhat similar. Not, of course, the exact same stuff, but you can probably imagine that you will get once more notational task and 1 or 2 refactoring tasks and using some patterns in some of them. Yeah. No, yeah, they should not be any bigger. It should be quite easy to finish it up in 90 minutes, I think. Not if you have understood and read, of course. So okay, then let's move on to the next assignment. So we have some code once more, and this code uses the model view controller architectural pattern, but it has a glaring problem. Your task is to identify the problem and solve it using a standard object-oriented method. You should update the code and make a correct UML class diagram over your solution. So we have a little bit of packages here. We have a model package and a view package and a controller package. And we have a model class called foo, and we have an interface for a view called iView, and we create an object of type view, and we have a controller of type controller, and we send in the model and the view to this controller, and stuff happens, and we call do on the controller, and off we go. And we save these two in member variables in the controller, and in the do function we have some code here, and if the user wants to do, the controller asks the view if the user wants to do, should probably be view here. I will change that later because I'm not logged in here right now. If the user wants to do some business logic, we call the model and does some business logic, and we don't get through back. We draw an error message. Otherwise, we draw the interface when the business logic is done. And the view has some function in it. It has an update progress function with some progress message and an interface to draw stuff. And this user wants to do business logic stuff and draw an error message. And we have the implementation of this interface also, and well, it's not interesting to go into the details of this implementation, so we have something there. In the model, we have a member variable of type iView. We use this object when we do some business logic to update the progress so that the user can see that, okay, this calculation probably takes a lot of time, and we need to show this progress we have come to the user. So we call the view and update the progress so that it can be displayed. And that's about it. So the problem is anyone? Exactly. We have a dependency, in this case an association here from the model to this iView interface, and we call this to show the progress in the user interface. So we had tied the model to a specific type of user interface, and that is not good. So this is a violation of the architectural pattern. So that is the problem, and how do we solve it? Yeah, but the problem is we only have this function here, and it takes a lot of time. So imagine this taking like 5 minutes, and we need to update the progress. So if the view can't really, it does not have the thread of control, so it can't call the model and poll it, so to speak, and ask, okay, how far have you come? because the thread of control is entirely in this do some business logic stuff. You could thread it, make a threading solution where the view actually calls this function. That could be a solution, but it is not, well, something that we have gone into in this class, and it would be quite more complicated than it needs to be. Yeah, we had another question? No. Yeah. And yeah. Yeah. And is it even working? Yeah. I think it should be working, but you never know. It depends a little bit on how this view is implemented. But anyway, the standard solution for letting the model send something to the user interface to notify it that it has been changed in some way, which is happening here, is to use the observer pattern to do this decoupling of these events. So we should use this observer pattern instead. So how do we use the observer pattern? We create a listener interface. I would actually like to have it in a non-UI specific way, as it seems also now these strings are like displayed directly, and this also is a tie to some specific type of user interface where you display this progress string on the screen in some form. In another user interface, you maybe have a bar that expands or something like that. So it would probably be better to give the listener a number between 0 and 1 or something like that. Because then it can decide, okay, I'm a user interface that would like to display this as a string, so I convert this number into a nice, good-looking string, or I'm a user interface that use a progress bar, so I convert it into this graphical representation instead. So a little detail, but using a float here is better. So okay, we also need to decide in what namespace this interface should be, what package it should be in. Any ideas? I have view here in this chat, and we have model here on campus. I say controller. No. So, okay, we need to think then. Who will be calling this progress changed function? It will be implemented in the view by some view type, but it will be the model that calls it. In here, we will not call the view. We will call some object that implements this interface that, okay, progress has changed now. So it must be in the model. So because otherwise we would get this relationship between the listener, between the model package and the view package if we put it in the view. But the opposite is, of course, fine, to have a relationship from the view to the model package. So to make it a little bit simple, you could add this registration and add it as a member variable or something like this, but just to make it not stretch out too much, we just remove that and we do this so we can send in a listener here, and we have this code, and I won't add all of it, but instead here we send 0.0. And it should be called a listener instead. And we will send 1.0 when we are done. And we need to have the view. If we select the view as, and you can actually select either the controller or the view to implement the interface. It does not matter actually. But I select the this type here. So it is also a progress listener, and we need to have this implemented. Convert a percent to a nice string. And we had an, and we call this function instead. Something like that. So, some questions here. When doing this with language constructs like callback functions or streams, is it still called observer pattern? Well, of course it's hard to answer that question, but sure, this is some type of callback functionality, but it is an object-oriented callback construction. And you could probably implement this using callbacks instead of objects in this way. If you would like to call it observer still, well, possibly. But it becomes more of an implementation issue, and I think that that keeping it in this. When we discuss the design, it is good to call it observer because then we all know what we mean. And then if you have implemented in C or some non-object oriented language using a callback function instead, that's another issue, more or less. What language are you writing just now, or are you mixing Java and C#? Yeah, it is probably some kind of a mix of Java and C#. And Java does not have package namespaces, it has packages instead. So it would look, if we have Java, you would write a package first. And package is also the UML name for what we mean. So using package would work just as fine. Yes?
Will this be suffice for a solution to this problem now that you excluded tons of code from the example code, but what you got here is only the solution, so to speak?
Yeah,
Would you want the entire thing
I think it.
with the equivalent solution implemented?
I think that this would suffice. I don't think we have.
A lot of this code is code.
Yeah.
Much.
Yeah, it is just there to kind of like explain how things work to you. So I think, for example, doing all these updates here, well, I can understand how this works now by just looking at these two. So that would definitely suffice. And just putting something like that would, well, okay, all the other functions are here also. So that would be good enough for me, I think. Yeah, actually, we have this. We have one more thing to show here, and it is. Yeah, I will just make a copy of this. Let's take the controller. Yeah, it is here. So you could, of course, add something like that just to be really, really obvious. I would not say anything about that. I would understand this also, because I know that this is an interface, and depending on language, the notational stuff is a little bit different here. But we have actually the controller left. So the controller does not work like this anymore, and we should send in the view here, like that. So that would also be needed, so that I know that, okay, you know what object to send to the controller, to the model when we do the business logic. What?
To send this something is that?
Yeah, not in this implementation. If I send this here, the controller must be the one to implement the interface.
With the view class, could you send this instead of passing the view object into itself and then passing it on as an argument?
Ah, sorry. It should of course be there. Questions? The question was just based on my mistake of putting the view object in this operation call instead of this one. That should obviously be the one that gets the view, since it is the listener of the events. And you could make a more elaborate implementation of the observer pattern here if you would like. For example, allowing the model to handle several listeners, having a list of listener objects and iterate through them and stuff like that. So you can have a little bit more of an elaborate implementation. You could add listener function and stuff like that. So, but this is the bare minimum I would expect. Any other questions? So I think this is exam number 7. So the question is, how many questions will it be on the exam? I'm thinking right now, I've not really decided 100%, but I'm thinking 3 questions. That is my current idea, anyway. Yeah, so 30 minutes for each task, and I think that is pretty okay, yeah. All right. If there are no more questions, feel free to add things to look into in the forum if you find something that we should do. Next lecture I will talk a little bit about some generic principles that you may have heard or not heard about. And that will be next week, and you also have the workshop next week. So prepare by finding a development environment and be up to speed on the patterns and refactorings and stuff like that. Okay, thank you for now.